Welcome back, everyone. Next we're going to look at the second part of the assignment, which is compound interest application. So we have 3 questions here. They're not overly complicated. It takes some time to work out, so what I'm going to do is work through them now. Taking a look at the first one. What is the worth of a deposit of $1,750 made into a registered retirement saving plan from March 1st, 2005 to December 1st, 2025 at 4.4% compounded quarterly? Well, let's take a look. First and foremost, we have to think about, I'm going to call this 1B. This is a deposit. Now, deposit is a fancy way of saying it's the present value. So the present value is $1,750. The time is from March 1st, 2005 to December 1st, 2025. Let's figure this out now. So this is 20 years and 9 months. 20 years plus 9 months. Okay? I'll come back to that in a second. Now, the other thing we're told here is that it's 4.4% and it's compounded quarterly. So what we need to do there is take our 4.4% annual rate divided by 4, and that will give us 1.1% per quarter, which is 0.011. Now, when we calculate this, when we're looking at these type of problems, the interest rate is compounded quarterly. So we really want to convert this time here to quarters. Well, let's think. 20 years, and there's 4 quarters in a year, so that's 20 times 4, which is 80, so that's 80 quarters, plus 9 months. Now 9 months is 3 quarters, so it's 83 quarters, and that corresponds to N. N is 83 quarters. Okay? That's the basic information that we need in order to carry this out. So we are calculating here, we know the present value, so we're looking for the future value. How much is it worth in a period of time? So the formula for that is 1 plus I to the n. So in our calculation, we know the present value is $1,750. Times 1 plus I, and we calculate that to be 0.011 to the n, that's to the power of 83. Okay, so that equates to, if we do the numbers, do the math on that, that'll come to $4,338.94. So in other words, what we are saying is that $4,338.94 is the value of the deposit in 20 years, 9 months. So that's how you do number 1. The second question says, determine the future value amount of $400 invested at 6% per annum, compounded quarterly for 3 years and 5 months. So similar problem to above. So let's just write down our baseline information. I'm going to call this one 2B. Our baseline information, determine the future value. We're looking for the future value. We don't know what that is. The amount is 400, so this is the present value, $400. The interest rate is 6%, and we notice that it's compounded per quarter. So what we do is we take 6% divided by 4, and that will give us 1.5% per quarter, which is 0.015. Okay, that's our interest, and then we next calculate our N, and our N is 3 years, 5 months. Now, everything is in quarters. Notice it's per quarter, so that is what? 3 years times 4 quarters plus 5 months is 1.6 quarters. So that's 12 plus 1.6 is 13.6 quarters. Okay, so that's how you calculate N. Again, we just plug the numbers into the formula, so FV equals PV 1 plus I to the N, so we just plug our numbers in. Present value is 400. 1 plus the I, we calculate that to be 0.015 to the N, which is 13.6. We run that through our calculator, and we will get $489.78. So in other words, that 478, which is roughly $490, is the future value of the investment. Okay, that's number 2. Let's take a look at number 3. Now, number 3 is a more in-depth one. And number 3 says, demand loan of $10,000 is repaid in payments of. So we have $10,000 coming in right up front. That's what we got. There's payments of $5,000 in year 1, payments of $6,000 in year 4, and a final payment in 6 years. Interest on the loan is 10% per annum, compounded quarterly. During the first year, 8% compounded semi-annually for the next 3 years, and 7.5% compounded annually for the remaining years. So what we have really is 3 problems in one here. We've got to calculate the first part with the first interest section, then we calculate the second part, and then the third part. So let's just plot this out in terms of a timeline. That's the easiest thing to do with all these problems. Is you really need to timeline them. So let's start off here. This is the $10,000 is what you got. Okay, so you got $10,000. 1 year goes by. Goes on tight. 1 year goes by, and you're going to pay back $5,000. Okay. Now let's just take a look at this first year first. Okay, so $5,000, and that there's a, if I read the problem correctly, it's 10% per annum compounded quarterly. 10% compounded quarterly. Okay, so there's our first. So we get 10,000. What we need to do is figure out how much is that 10,000 worth at the end of 1 year, and then we make a $5,000 payment on it. Okay. Then the balance of what's left. So I'm going to call that part A. So this year is part A. Then I'm going to go and it says, okay, from year 1 to year 4. In year 4 it says we're making a payment of $6,000 minus 6,000. And that year 4 is 8% semi-annually. So I'm going to call this B. So again, we have a beginning amount here. It's going to accumulate 8% semi-annually. We're going to calculate what the value is at year 4. And then we're going to take $6,000 off it because someone's paying $6,000. The final section, year 4 through year 6. At year 6, we're going to pay off the loan. So the full amount, whatever the balance is here, that's what we're going to pay off. That's the mystery amount. I'm going to put a little question mark there. I'm going to call this section C. And by the way, it's 7.5% annually. So here's our 3 problems. So let's calculate the first problem first. So I'll highlight. I'm only going to do this section here first. Okay, so what I want to do is figure out how much $10,000 accumulates to in 1 year, and then I'm going to subtract $5,000 off it. So let's take a look. I'll call this A. So the present value is $10,000. The time is 1 year. The N, well, we have compounding quarterly, so that means there's 4 quarters. So that's 4 compounds. N is 4. The interest is 10%. It's compounded quarterly, so I divide it by 4. That's a 2.5% per quarter, which is 0.0025. So again, let's just plug it in. So the future value then is the present value, 1 plus I to the n. Present value is 10,000 times 1 plus I, which we calculate to be 0.0025. 0.025, sorry, I'm not watching my decimals here. 0.025 to the n, which is 4. I'll run that through my calculator, which I've already done, and I get $11,038.13. What that means, so just be careful here now, is that $10,000 will sit accumulating 10% compounding quarterly. At the end of year 1, it will have this balance. Okay, 11,000 change will be the balance. Now, remember, we're going to make a payment of $6,000 here. Okay, so the balance then, after that payment is made, is, we're making payment 5,000. That's the next one. We're making payment 5,000. So the payment is 6,038.13. So that 6,038.13 becomes the beginning balance for this part B. So 6,038.13. So here we go. Now let's look at B. The B, the present value, in other words, the beginning balance, is 6,038.13. We have the time, 1 year to 4 years is 3 years. The N, it's semi-annual, so that's 2 compounds a year for 3 years is 6 in that case, which is 3 times 2 payments a year, or 2 compounds a year, sorry. And I is 8%, and it's semi-annually, so 8 divided by 2, which is 4%, which is 0.04. Okay, so now let's throw that into this formula. If V equals PV, 1 plus I to the n, so this is 6,038.13, 1.04 of just 1 plus, same as there, to the sixth, and that will come out to 7640.16. So what we're saying is if we take that 6,038, which we started at year 1, let it sit at 8% semi-annual, at the end of year 4, it will be valued at $7,640. Then we make a payment. There's a payment made of $6,000. So that payment comes in, subtracts off that. That means the balance is 1640.16. Okay, so that's the balance at the end of year 4. So 1640.16. So now the C part says, okay, we're going to take this 1640, we're going to let it sit for 2 years, year 4 to year 6, and it's going to accumulate 7.5% annually. In other words, that will give us this value here at the end. So let's take a look at C. C, the present value, then is 1640.16. The time is 2 years. The N, now it's an annual compounding, so that's N is 2. And the interest is 7.5%, which is 0.075. We put this in FV equals PV, 1 plus I to the N. Present value is 1640.16, 1.075 to the N, which is 2. And if we crunch the numbers on that, that will come to 1895.41. So what is this saying to us? This 1,064.16 balance at the end of year 4 sits for 2 years earning 7.5%. At the end of that 2 years, it will have a balance of $1,895.41. So in other words, to pay off this loan, we need to make the final payment of $1,895.41 must be made to satisfy the loan. And that's how you do that problem. Let me know if there are any questions. Thanks.